There is absolutely no basis at all for thinking the world is flat. Nobody in human history, as far as I know, has thought the world was flat. Greeks measured the radius of the earth. I cannot conceive of a reason why anybody would think that the world is flat. There are interesting bits of physics that tell you that you live on a spinning planet. One of them is called the Coriolis force, which is the force that's responsible for causing storm systems to rotate on the planet.
Part 4. Coriolis effect explained. Bullets and spinning objects, the Magnus effect on the flat Earth. How does our model correctly account for the Coriolis effect on bullets and long-range shooting? Again, the answer is simple, and the controllers got it wrong. They officially call it the Coriolis effect, but it is not. Here's a diagram of the official explanation of the Coriolis effect on bullets. The apparent deflection of a body in motion with respect to the Earth and caused by the rotation of the Earth. Deflecting right in the northern hemisphere and deflecting left in the southern hemisphere. The official explanation is complete rubbish. The Earth does not spin, rotate, or move. Rifled barrels are used to create the spin of the bullet. The spin stabilizes the bullet in flight, but also creates the deviation from the expected path of flight. Here's a diagram of what happens to a bullet in a rifled barrel and then a smooth bore barrel. The real answer, the Magnus effect. As the ball is spinning, there's friction created on one side, and then the air flows freely on the other side. Magnus effect, the force exerted on a rapidly spinning cylinder or sphere moving through air or another fluid in a direction at the angle to the axis of spin. This force is responsible for the swerving of balls when hit or thrown with spin. A spinning rifle bullet. Magnus effect, not Coriolis effect. The Magnus effect on spinning rifled bullets work the same as spinning balls in forward motion. Again, like always, the answers are simple. Another diagram of air flowing over a spinning ball. Examples of the Magnus effect. Baseball pitches, curve, slider, fastball. Tennis, topspin, slice, drop shot. Golf, draw, fade, cut, slice, etc. Sideways spin or a spiral action will deviate left or right, as in a football or rifled bullet, depending on the rotation of spin. A front to back or back to front spin will deviate up or down. Think top spin or backspin on a tennis ball.
So when you see those beautiful pictures of storms spinning around and rotating, the reason for that is that we live on a spinning planet.
Cool story, bro.
But there's some nice physics in there actually, if you want to dig more deeply. Putting all that aside, the theoretical stuff, the very simple fact that we've taken pictures of it, you see, I'm lost for words. It's probably the most nonsensical suggestion that a thinking human being could possibly make. It is drivel. It's a great question. Can we populate Mars, and if so, how would we do it? The answer is absolutely yes. We've discovered through space missions over the last few decades that there are vast amounts of water on Mars. There are minerals on Mars, very similar to the minerals you find on Earth. So essentially Mars has everything you need to build and sustain civilization, to allow settlers to colonize the planet. So there are plans now, real plans, to colonize Mars, to get people to Mars and begin colonization. I think we're going to go there. We're going to go there within a decade or two, and everything you need to survive exists on the planet. It's a good question about whether there could be other universes in which time runs in a different way, a different direction. The first thing to say is there can be other universes. In some sense it depends how you define the word universe. Theoretically there could be other bubble universes like ours, where the laws of nature that you see in those universes are different. So that's a possibility. Now, as to time, Stephen Hawking once said, in A Brief History of Time actually, said that he thought that if the universe recollapsed, then the arrow of time might be reversed and time might run backwards. He then corrected it and said no, he doesn't think that anymore. The honest truth is that we don't have a very good understanding of time. So exactly what time is, how it behaves. We have understanding in different frameworks. So Einstein says that it's a dimension, a bit like space, and talks about a thing called space-time. In quantum theory, our theory of the subatomic world, we have maybe a different picture. So the honest answer is we don't fully understand yet precisely what time is, and it's one for the future. Great question. How big is the universe? Is it infinite or not? The answer is we don't know. What we can say is there's such a thing as the observable universe, which is how much of the universe can we see from the Earth. So think about looking into the sky, let's say the Andromeda galaxy, which is the nearest galaxy to the Milky Way. It's just over 2 million light years away. That means that light takes 2 million years to travel from that galaxy to our eyes, which means that we see it as it was 2 million years in the past. Now, the universe is 13.8 billion years old. So that means that we could only ever hope to see light from something that is close enough that the light has been able to get to us in 13.8 billion years. And that
cool
thing,
story,
the furthest we can see, is called the cosmic microwave background radiation. So it's the glow, it's actually the afterglow of the Big Bang itself that we can see if we look far enough out into space and therefore far enough back in time. So you'd ask the question, how big is that bit now? So the universe has been stretching and expanding over all that time during which the light has been journeying across it. So if you say, where's that point now that emitted that light that's just reaching my eye now from the beginning of time, from the Big Bang? It's about 42 billion light years away. Or something like that, just over. So we've got a big sphere, 90-something billion light years across, filled with 2 trillion galaxies that we can see. Is there anything beyond that? We strongly suspect so, but we can't see it. And does that go on forever? We don't know.